This is the video for Chapter 2, Part 1. For Chapter 2, this is going to be a little bit different because I don't think that the actual ideas in Chapter 2 are, hopefully they're not too difficult to grasp. It's more of an idea of wanting to know what you need to focus on and what I'm going to be expecting of you from the frequency distributions versus the various graphs that are covered, and then that last section of graphical misrepresentations of data. So what I'm going to do is go through that ESOL lens and just look at each of my expectations and where they fall. So that's what this video should cover. Alright, so there are several things within this chapter that more or less I just want you to know that they exist, and perhaps that you know that you will be able to create those certain graphs using Excel, StatCrunch, or some other application or program that would be available to you if you were expected to make things like a pie chart. I'm sure we all know what a pie chart looks like. As far as the existence of how to make one, I do not want you trying to figure out with a compass and protractor of how many degrees each portion of a pie chart needs to be. That's just not something that I want you to even think about trying to do. You can make beautiful pie charts and bar graphs and Pareto charts using Microsoft Excel, or like I said, for this class, StatCrunch. So as far as those like very detailed, how do I make these by hand, those are things that just, the general idea of it is more important to me than your actual ability to draw me a pie chart. So please keep that in mind. Some of the other things as I'm flipping through and kind of scrolling through the guided notebook, the things that you would have found and seen in the interactive assignments. One is probably doing the histograms of continuous data. So again, I want you to understand what those frequency distributions look like. Of course, for discrete data that have a small number of possible outcomes, like in example 2, we're talking about number of customers at, looks like at Wendy's, and you had number of customers were between 1 and 11. So that's fine to just let each one of those be its own class. But when you're trying to figure out continuous data, or data that has a much larger range of numbers, then being able to come up with what the lower class limit and upper class limit should be is not something that I want you to have to try and worry about listing out all the classes. Now, I will talk about class width, that's very important, on another slide. But you are not going to need to try and make these classes yourself. I want you to be able to read it, understand what those numbers are. The lower class limit is the smallest number that would go in. The upper class limit is the largest number that would go in. There should not be any gaps. Those are things that you need to know, but trying to create those are not important. And then I was just trying to see if there's anything else that were stem and leaf plot. Know what it is, know how to read it. Being able to make it is very kind of in there. It'll probably end up being on the next slide. Cumulative and cumulative relative frequency, understanding what those are is also important. If you see anything about an ogive, and it's spelled, that's a J sound though when you pronounce it, you do not need to know anything. Honestly, even if you don't even need to know it exists. But if you see anything about that in the interactive assignments, don't worry about it. Things that you should be able to do supported with your notes, and things, you know, like if later in life you need to be able to do things, being able to make graphs in, I'm going to go ahead and just say Excel, etc. Whatever program you might be using. There are plenty of different ones other than just the Microsoft Excel, but there we go. StatCrunch, Excel. There's another program called R that is a free statistical software. There's lots. So if you can make those graphs, then you don't need to be able to make them by hand, and that's fine. The other things that would probably fall under this category, dot plots, things like that. So that goes to graphs as well. So basically creating any of these graphs, there's no reason that you wouldn't be able to look up instructions or be able to have notes for that, be able to reach out to someone for something like that. So now, if it's on a test, then it needs to be in your notes, not reaching out to someone. So please remember that on your test. I'm expecting you to be doing all of the work. If you have something written in your notes or something like that, that's fine. But you do not need to be getting help from someone else for tests. But as far as supported, just any of those making graphs type things should be fine with help from instructions. The things that I want you to be able to do independently, and this will kind of bleed into that lifelong, that L part of our lens, is to be able to reading a graph. So can you read any of these graphs that we have? Other things that you should be able to do is recognize the differences between graphs. So, for example, the difference between just a bar graph, a Pareto chart, and a histogram. And there are differences between those. They all kind of look the same in the sense that they have bars to represent things, but otherwise there are differences there. So you should be able to recognize those differences. So you need to be able to read graphs, know the differences between graphs. Obviously, if I say stem plot versus dot plot, you need to know the difference between those as well. Being able to read a stem plot is important, something you should be able to look at a stem plot and understand what those data started off as. So as far as the lifetime set of things that I hope that you will leave with from this class, can you maintain the skill for a lifetime success? That's just going to be basically all of, I guess, reading the graphs, but just understanding displayed data. That is something that when somebody throws a graph up on the news, or you see it in a newspaper or online somewhere, what is that? How did that graph come to be? Has someone done something to that graph to make it look a certain way? And so that gets into that manipulation and misrepresentation of data that those are things that you want to see. So those graphical, and I'm gonna include intentional, so manipulation, and then just misrepresentation. Sometimes we don't mean to misrepresent the data. It just happens. So manipulation and graphical misrepresentation of data. So those are things that you should be able to look at and understand. One of the great misrepresentations that were just in your guided notes and in the interactive assignment is just example 1. So it's got this home security company develops a summer ad campaign with the slogan, when you leave for vacation, burglars leave for work. And so roughly 20% of home burglaries occur during the peak vacation months of June and July. So then we've got June and July, and then all of the other months. Well, that actually could be stronger if they would just put all 12 months out, because then June and July individually would both be much higher. Let's say it's 10% each. It may not be. But even if they're 10% each, you've got 10 other months that are at less than 8% total. And then I think there's also an issue here. 20% occur during June and July, or July and August. and 7.9%, 8% are contained in the other months. That does not add up to 100%. So where are the other burglaries? So that's something to think of about as well. So I don't know what all I don't remember what all they point out. Other things can be not having that 0 starting point on the vertical axis. That's very big. And then just trying to get a little too flashy with 3D stuff, or even just two-dimensional stuff or artsy things. Those things can really mess things up.